Welcome to my channel Physics Incline. This is MS Rao. Today we are going to make a discussion on optics, which belongs to 12th class syllabus. Now the optics is classified into two groups. One is geometrical optics. This is also known as ray optics, and other one is physical optics, and it has two classifications: wave optics and quantum optics. Right? So initially geometrical optics or ray optics. So what is its definition? It is a branch of optics which deals with the phenomena of rectilinear propagation, reflection and refraction of light by the concept of ray. So second one, wave optics. What is wave optics? It is also a branch of optics, deals with a phenomenon of interference, diffraction and polarization by the concept of wave. And what is quantum optics? It is also one of the branches of optics which deals with the phenomena of photoelectric effect, Compton effect, with the concept of stream of particles. Right? So overall, this optics is classified into three parts: geometrical, wave optics and quantum optics. Of course, this wave optics and quantum optics will be discussed later. This belongs to another chapter. Now let us move on the first part, that geometrical optics, which is also known as ray optics. So basically this ray optics is how we discuss what kind of concepts, which includes mainly we focus on, what is the rectilinear propagation of light and reflection phenomenon and refraction. And in reflection at plane surface and reflection at spherical surface, which is also known as spherical mirrors, concave mirror and convex mirror. Right? Whenever we go for refraction, in the refraction part we make a discussion how the light refracts through plane surface and its applications and Snell's law. And second one is total internal reflection and its applications. And third one is refraction through prism. And fourth one is refraction through spherical surfaces, and followed by the lenses. This is briefly all about the concepts related to ray optics. Okay, next we go for rectilinear propagation. Rectilinear propagation. Guys, here you should keep in your mind that geometrical optics is a special case or a limiting case of wave optics. Whenever the size of the obstacle and size of the slit much greater than that of the wavelength of the light used, under which the wave nature of light is ignored, only the ray optics, by which the geometrical optics, their corresponding phenomena are to be discussed. So whenever the size of the obstacle and size of the object or the opening are comparable to wavelength of the light used, under which the ray optics, that is the geometrical optics, or the rectilinear propagation. The rectilinear propagation is ignored, then under which only wave nature of light is to be used. Through wave nature we can discuss interference, diffraction and polarization. Right? The next we move on reflection of light. So here rectilinear propagation, what does it mean? It is a property of light by which it travels along a straight path unless until the medium was changed. So that is the property simply. Now here the light, regarding the light concepts, to understand properly, we should know the basic points often we use, basic terminology or words often we use in this chapter. That is beam. What is beam? What is a convergent beam? What is a divergent beam? What is a parallel beam? So we should know about these classification of the beam. And next, what is object? So how many types it has? Real and virtual object. Let us start from the beam here. The beam, it is a bunch of light rays, bundle of light rays known as beam. So that beam is of three types. One is convergent beam, second one divergent, third one is parallel beam. What is a convergent beam? So in this case, the diameter of the beam decreases in the direction of incident light. Now, a divergent beam. So in this case, the diameter of the beam increases in the direction of incident light. That is, as we are moving from this point to and away, that in the direction of incident light, then its diameter increases. Therefore, it is a divergent beam. So, in this case, convergent beam, from here, if you go in the direction of incident light, then its diameter of the beam decreases. Therefore, it is convergent beam, and this is divergent beam. And if you go for parallel beam, in this case, the diameter of the beam neither increase nor decrease in the direction of incident light, which is taken to be parallel beam. Now, let us move on the object. What is object? So, object in case of optics, the object meaning is different. So, this is also known as, so that it is called as optical object. General object and optical object. Our meaning is different. So here optical object means optical object is decided by the diverging light only. So what is the meaning of divergent light? Diverging light. Suppose if you consider an object from which the light is diverging, coming out, moving away from the source, moving away from the object. So in such case, the light is diverging. Means here, already we discussed in this case, diverging beam. So we can take this application there. Here, the light is diverging from an object. See this object. And the light is started from this object. This light is diverging into the space, spreading into the space. As a result, its diameter increases. Whose diameter? The diameter of the beam which is emerging from the source or emerging from the object increases. Therefore, that is taken to be real object. Of course, here optical object is decided by the diverging light only. Right? There are two types of objects. One is real object, other one is virtual object. What is real object? So it is an object which is taken to be real whenever the light is diverging from it. The point of divergence is taken to be real object. So here everything in the nature. So whenever it is visible for a human being, and everything that is taken to be real object. Suppose you are observing that bus is moving, you are observing book, you are observing anything in the nature. So that is taken to be real because the light is diverging from an object that fall on the eye of human being, then he can able to see that object. Therefore, those objects are taken to be real objects. That is possible whenever light is diverging from the object, that object taken to be real object. Now go for virtual object. So in this case, light converges to a point. The point of convergence is taken to be virtual object. So in this case, it's very clear, keep in your mind, it's a very important point. So here virtual object, can you see? So I cannot be see the virtual object because the light converges to that point. The light is converging to this point, not diverging from it. Therefore, whenever the light is converges to the point of convergence is taken to be virtual object, so that we cannot see that object. Because the light is not coming from that source. Light is not coming from that object. So it is not visible to the eye. So in this case, so finally at final, it's very clear, virtual object can't be seen. Virtual object can't be seen. Now if you go for a suitable example to understand, here it is a plane mirrors and an object is keeping over here. So from this object, the light rays are diverging in all possible directions. Of course, the rays are diverging from it, therefore it is taken to be real object. And it is incident on the plane mirror. And after reflection, the reflected rays are extended. Then image is formed here. Of course, this image is considered as an object. Then that object is taken to be virtual object. Why it is virtual object? So here, by the law of reversibility, what is the meaning of it? If the light rays are reversed there itself, then so its image, that image will be converted into object. So here also, the light rays are diverging from it after reflection. Yes, these light rays are reversed. Just these light rays are reversed. They are converges to a point. The point of convergence is taken to be virtual object. Therefore, this is a way exactly to distinguish real object and virtual object. So this is real object and this is virtual object. Okay, the next. So next we discuss regarding image. So here optical image is decided by the reflected and refracted light only. So that image is of two kinds. One is real image, other one is virtual image. So once again I repeat, the optical image is decided by reflected or refracted rays only. So this image is of two types. Number one, real image, and other one is virtual image. So what is the real image? So this real image is formed due to real interception of light rays. And this is go for example, taking lens, convex lens. This is object. And from this object, the light rays are incidenting on the lens. And these light rays after refraction, so already in the definition it was mentioned. So that image is formed. The image is forming by the reflected or refracted light rays. Therefore, if you are taking one of the examples, refracted case, then it is a lens. Object is keeping in front of it. The light rays are refracted through lens. And finally, the light rays are directly meeting over here. Whenever, wherever the light rays are after reflection or by the refraction, the light rays are directly meeting each other, definitely you will get a real image. There is no question at all, there is no doubt at all. Right? Keep in your mind, this is giving the real image by the convex lens. In this case, right? So this is a suitable example to understand what is the real image. And real image is obtained on the screen. So we can catch on the screen. And if you go for examples in our daily life, live examples, in the cinema theater, the movie on the screen, that is real image. And our photograph in the photo studio. So our photograph is taken in the photo studio. So he will give our photo on the paper. So paper is taken as screen on which our photo is the image. Which image? Real image. And also in case of human eye, suppose we are observing object, how it is possible? So object is seen means its image is formed on the retina of eyeball. So in between these two there is a convex lens in eyeball. Therefore image formed on the retina is the screen and its image is formed on it. Therefore that is also taken to be real image. So real image can be obtained on the screen, and we discussed or we given different examples to understand the real image. Okay, let us move on virtual image. What is virtual image? So this image is formed due to virtual or apparent interception of light rays. Apparent interception of light rays means these light rays are not directly meeting after reflection or after refraction. So they are extending backside, the intercept will give its corresponding image. So moving backside, extending backside, giving interception is known as virtual interception or apparent interception of the light rays. If you go for example, now here there is a plane mirror. So an object is keeping in front of it. This is object. And from this object light rays are incidenting on this plane mirror. So after reflection, the light is reflected like this. So keep in our mind, when the light is incidenting normal to a plane mirror, that will be reflected along the same path. So whenever it is incident at some other point, that is reflecting with certain angle, that depends upon angle of incidence. We discuss regarding this one later. Now this is light reflected. So this reflected light is extended backside. Actually this is a plane mirror. This is plane mirror. Light incident on it normally and reflects back along the same path. And one more light ray is taken here incident and reflect like this. Now this reflected ray is extended back. This reflected ray is also extending back. They are intercepting each other. That is apparent interception of light. So by this apparent interception of two light rays which are extending back and which gives the position of virtual image. So this is how we understand the virtual image is formed. That by taking a suitable example, a plane mirror. So plane mirror is giving virtual image for real object. Keep in our mind. So some confusions will be there. The students often confusing. Actually, the plane mirror is there. So plane mirror is always giving virtual image. This is a wrong statement. Plane mirror will also give real image. How? It depends on kind of object. If object is real, definitely your statement correct. For real object, plane mirror is giving virtual image. So plane mirror will also give a real image. The real image is possible when object is virtual. Regarding real and virtual we discussed just now. Right. If you go for one suitable example, note, keep in our mind, note. Here, a plane mirror is always not giving virtual image, which can also give real image. So, example, a person is standing in front of a plane mirror. Okay, we can see its example in our daily life. Every day we are observing, we are seeing our image in the plane mirror, right? So whenever you stand in front of plane mirror, you will be the real, you will be the real, and you are taken to be real object. And from you, the light is diverging in all possible directions. And this light is incident on the plane mirror. After reflection, then what happens? The image is giving virtual. Just now we discussed over here. Yeah, similarly, here the person is standing in front of plane mirror and the light is reflecting. After reflecting, the reflected light rays are extended. Then its corresponding image, see, virtual interception or apparent interception of light. See here, the light is reflected over here, the reflected light is extending back and reflected light is extending back. Then the image is formed there by the apparent interception. That image is virtual image. Virtual image. Of course, this is a real object. Real object. Keep in your mind a very important point. See here, the object and image both will exchange each other whenever the light is reversed there itself. Means this is known as law of reversibility. Law of reversibility. Whenever the light rays are reversed, everywhere the light rays are reversed. When the light is reversed, then so this image already formed virtual, that image is taken to be object. This converts into object. Which object? Already we discussed. The light converges to this point. Therefore, this image is taken to be object. Which object? The point of convergence taken to be virtual object. Therefore, it is virtual object. Yes, earlier it is virtual image. Now it is virtual object. And corresponding virtual object is giving, so image formed is real. Earlier it is real object. Now it is real image. Very simple. This is just we reverse the light there itself, we can understand this image and object both are interchanged. It's a very simple logic to understand this one. Keep in your mind finally. So plane mirror can give real image and virtual image. But note, virtual image is giving whenever the object is real. Real image is giving whenever the object is virtual. This can be understood by law of reversibility. Okay, the next we move on other part. Yeah, before going to another part, I will remind once again here the virtual image cannot be updated on the screen. Keep in our mind. And the virtual image is formed by plane mirror. Yes, and also convex mirror always giving the virtual image. For real object, keep in our mind. And here the convex mirror is also giving real image. We will discuss it later where we discuss regarding the spherical mirrors. Okay, the next keep in our mind. So virtual image cannot be obtained on the screen, and virtual image is obtained or getting by the plane mirror and also convex mirror. And concave mirror is also giving virtual image under specific circumstances. We will discuss it later. Now, let us move on some important results concerning reflection of light by plane mirror. So, image formed by the plane mirror is virtual and direct and perverted image. Now, the second point is size of the object equal to size of the image. Both will equal. Size of the object and size of the image, both are equal. Now, distance of the image will be equal to distance of the object. It's a very important point. Distance of the object and distance of the image. O m is equal to I. Sorry, mi. Distance of the object equal to distance of the image. Next point is image formed far behind the mirror as the object is in front of it. Don't think of that. The image is stick with the surface of the mirror. It's not possible. So image is always formed far behind. That depends on the position of the object. Now go for another one. So whenever object is moving towards a plane mirror or away from plane mirror, stationary mirror. Once again I repeat. Whenever object is moving towards or away from the plane mirror, which is stationary, then image is also moving with the same amount and also having the same speed. I repeat once again. So object is moving towards or away from the plane mirror by x, say. So its corresponding image will also shift by the same amount. We can prove it. Very simple. So distance of the initial case, distance of image equal to distance of the object. The condition is there, mi. So next point, mo dash is equal to mi dash. So here I dash is equal to mi minus mi dash. Mi is equal to mo minus mi dash equal to mo dash, which is giving simply x. So here whenever object is shifted by x towards or away from stationary plane mirror, the image will also shift by the same amount. Similarly, if object is moving with certain speed, constant speed towards or away from the plane mirror, the image will also moves with the same speed. So how? When we differentiate this, you will get same amount. Here, suppose x equal to x, whatever the shifting takes place by the object and the same amount of shifting taken by the image. Therefore, if it has a constant speed, the same speed with which the image will also move. Right? The next we move on another part. Suppose instead of the plane mirror, instead of the object, so we consider that the plane mirror is shifting. So object is stationary, is at rest. The plane mirror is shifting towards or away from the stationary object. Then what about the shifting of image? Let us see. This is the plane mirror. If the mirror is shifted by x, now beginning case, whenever the mirror is shifting by x, definitely its corresponding image will also shift by some amount. Let us find that. So here this is m and final position of the mirror m dash. This is initial position of the image and final position of the image. Let us find I dash, shift of the image. So before going to this calculation, so conditions. Initial case, distance of the object mo is equal to distance of the image mi. Final case, final position of the mirror with reference to that one, final position m dash o is equal to m dash I dash. Now here I dash equal to m dash I minus m dash I dash. So here m dash I is equal to m dash I is equal to, so what we can write, x plus m dash I is equal to x plus mi, x plus mi. The next minus m dash I dash is equal to m dash o. We can substitute this value over here. m dash o m dash I dash equal to m dash o. Now x plus mi is minus m dash o is equal to, from here m dash o is equal to, we can write mo minus x. Mo minus x is giving m dash o. Therefore x plus mi minus mo plus x, and here 2x mi is equal to mo from the relation of fundamental. Therefore these two gets cancelled and finally giving 2x. So the result is shifting of the image is 2x. Whenever object is shifted by x towards or away from the, when mirror is shifted by x towards or away from the stationary object, its corresponding image will shift by 2x. Whenever the mirror is moving with certain speed, say towards or away from stationary object, and definitely image moves with double the speed of the mirror. So here, if you go for example, suppose the mirror is moving with a velocity of 10 meter per second, then here image speed is becomes 20 meter per second, double, because here the mirror shifted by x, the image shifting by 2x. Therefore here mirror is moving with a certain speed 10 meter per second, the image speed becomes 20 meter per second because it is becoming double. So this is next point, and go for another one. So here one more point is, a person wants to see his full image. Suppose his height is, total height is h, wants to see his full image in a plane mirror. So what will be the size of the mirror required? So here keep in your mind at which position mirror is to be kept to see the full image of the observer or object or the person. So there is a condition that upper edge of the plane mirror should be just above the eye level, that is at the level of forehead. Now the mirror is keeping it above the eye of the person, say it is h dash, we don't know its height, but person height is h. Now from the head light is incident on upper edge, and after reflection it is reaching to eye of the person, therefore he can able to see his head in the plane mirror. And similarly from the foot, light incidenting at the lower edge, and after reflection it reaching to eye, then he can able to see his foot. And finally these reflected rays are extended, and this is the image of this person. Now this is already we know the condition, height of the object equal to height of the image. This is the fundamental already discussed before. Now distance of the object equal to distance of the image. This is also discussed at the beginning. Now from these similar triangles, see, say it is eye level E, this is mirror m dash or m dash, here this is AB, this is A dash, B dash. Now A dash, B dash, E and m dash E are similar triangles. From these similar triangles we can write it as h dash by x is equal to h by 2x. Now h dash equal to h by 2. So very clear. Height of the plane mirror required how much? Half of the height of the person. So this height is required to see the full image of the person in this plane mirror. The minimum height required how much? H by 2, half of the height of the person, right? So whenever a person wants to see, go for another one. Another application. Suppose a child is standing somewhere here, and his father is standing behind him. Now, a child is standing somewhere here, whose height is smallest, and his father's height is double that of the child's height, and the father is standing behind him, and a plane mirror is keeping here. Now, in the figure shown, it's very clear. From the mirror, child is standing at a distance L, and the distance between child and his father is also L. Now, so what is size of the mirror required in order to see the full image of his father seen by the child? Now, here let us consider a ray from the head of the father, and the light is incidenting on the plane mirror, and after reflection reaching to eye of the child. Now similarly, from foot of the father, the light is incidenting on the lower edge of the plane mirror. After reflection it reaches to eye. Now these two are extended. Reflected rays are extended, and these extended rays are giving the image of the father, 2H. Now here, a distance of the object from the mirror, distance of the object will be equal to distance of the image. Therefore, distance of the object is 2L. Therefore, distance of the image is also 2L. Size of the object equal to size of the image. Right? The next here, this is eye position. This is AB. This is A dash, B dash. Now this is M dash. So here, triangle M dash E and A dash E are similar. Therefore, this is a H dash. Say, now H dash by L is equal to 2H by, from here to here it is 3L. Therefore, the minimum height of the mirror required is 2H by 3. So this is the answer. And this is the way. First of all, keep in our mind. So the making diagram by the rays after reflection and extensions, when you make it proper, then you can easily find its answer. No need to go in a lengthy way. Okay? Therefore, here this is one problem. And other one is, I am giving a question. Think of and give its answer. Suppose here, the minimum size of the mirror required in order to see the full image of his father when seen by the child. But the question is, when the father is seen, the image of the child, full image, what was the size of the mirror required? What was the size of the mirror required? So try it and give its answer. Okay. Then next we move on. One more point here. Consider this is a room. In this room, a person is standing somewhere inside the room. So from front wall, he is at a distance of X, and from rear wall at a distance Y. Now a mirror is hanging over the front wall. Now this person wants to see the full image of back wall in this room. What will be the minimum height of the mirror required? See here, from back wall, ray diagram, see carefully. We are taking the ray from back wall, from here, upper edge. After reflection, reaches to eye. And from here, lower edge of the wall after incident and takes place reflection, and they are extending finally reflected rays, and final image is formed for this back wall. This is a H, this is a H dash, this is also H. Now this is I position, M dash, A, B, A dash, B dash. Now here M dash, E and A dash, E are similar triangles. Similar triangles. Therefore, H dash by X is equal to H by. So here, keep in our mind, this is X plus Y over overall. From here to here X. It is from here to here Y. This is the distance of the object from the mirror. And distance of the image from the mirror is same. How much? X plus Y, clearly. Therefore, H dash by X is equal to H by, see here, X plus Y, which is giving final H dash equal to H X by 2X plus Y, and this leads to H by 2 plus Y by X. This is the formula. Suppose if any extra cases are asked in this case, whenever the person standing at the middle of the room, therefore X equal to Y. When X equal to Y, we can get the minimum height of the mirror required 2 plus 1, which is H by 3. And you can ask any question by representing or giving by giving the position of the person. You can easily find the minimum height of the plane mirror. Okay, thank you.